Good morning to all. Let me discuss the same electronic circuits one. The next topic we are concentrating on the power supplies. So before going to power supply, we need to understand the topic called rectifiers and filters. Let me start with the topic called rectifiers today. The topic is called as rectifiers. What is rectifier? Rectifier is converting of AC to DC signal. When you are giving an input signal as AC, you are going to convert into the DC signal. This is point number 1. Point number 2, types of rectifier. What are the types of rectifier? It will be split into 3 types. One is called as half wave rectifier. Other one is called as full wave rectifier. Other one, continuation of this one, full wave with bridge rectifier. So in this half wave rectifier, we are using only one diode. In full wave rectifier, we are using 2 diodes. In bridge rectifier, we are using 4 diodes. Okay, let us start with first half wave rectifier, then we will go for full wave, then we will go for the bridge rectifier. Now the topic is called as half wave rectifier. Half wave rectifier. Draw the circuit diagram first. We have to draw the circuit diagram. Okay, first very important one is diode. This is anode, this is cathode. It will be connected with the transformer. This is called primary transformer. This is called secondary transformer. Followed by the resistor, load resistance RL. Connected together, then directly it is grounded. There are totally point, 2 point, and one more point. It is also directly connected to the grounded. There are totally 3 wires for the transformer. It will be maybe 9 volt or 270 volt. 50 Hz frequency. Okay. So what is the input this side? Is AC default. What is the output this side? This is a DC output. That is called pulsating output. So when I give the input AC signal, I will get the output like this. But definitely I won't get the output like a direct DC current, right? So the current will vary. Definitely you get some like a pulse wave. I want to convert this pulse wave into direct wave. I want to convert this pulse output into direct. There I need filter. There, what are the filters are possibilities? C filter, L filter, LC filter, CLC filter. So there are 4 filters are there: C filter, L filter, LC filter, CLC filter. The CLC filter is also called as pi filter, where usage of this filter converting from DC pulsating to directly output DC line. It is going to convert into pulse line, it is going to convert like a direct output DC line. Okay. For this the waveform is the output of this half wave rectifier. This is my output waveforms. Take the input signal. This is my input signal with respect to omega t time period. Now I am connecting only one diode at the time. That is called half wave. So one diode means only positive cycle will come, negative cycle will not come. So first we have to draw the line like this. Okay. It will connect only positive cycle alone. negative cycle will not come, because the diode will act as at the time of only one cycle, only positive cycle instead of the negative cycle. So what is the final output? You will get only like this. This is the output waveform for the half wave rectifier. When come to full wave rectifier, the same thing, this is also will be activated with a negative cycle. Therefore, we will get the output. Connect like this, we get the output like this. Both positive cycle, negative cycle, positive cycle, negative cycle, positive, negative, positive, negative. Keep on. So this is called as ripples. The word is called ripples. That's what we used to find what is called ripple factor. How to find ripple factor? How to find rectifier efficiency? How to calculate transformer utilization factor? These are the parameters to find for the rectifier topics. For this diagram is, we are going to connect two diodes. This is for full wave rectifier with parallel of one resistor RL with the transformer. This is a diagram for full wave rectifier. This is the output waveform for the full wave rectifier. So okay, finally I'll tell you what are the parameters. In next session we will discuss about the derivation of all the parameters. So what are the parameters you need to calculate? So we want to calculate the parameters called parameters. So power at DC, power at AC, current at DC, current at AC, which is called as RMS. Then we call as voltage at DC, voltage at AC, then called as rectifier efficiency neta. Then it is called as ripple factor gamma. Next, transformer utilization factor. Last one is peak inverse voltage. Then final one called as voltage regulation. These are the parameters we need to calculate for all the rectifiers, including half wave or full wave or bridge rectifier. Okay, thank you students. We will discuss about the derivation of these parameters in the next session.